no other concepts to be memorized, no elastic curve to be drawn, no equations from elastic curve to be drawn, no moment diagrams to be drawn, just the moment equation. Sa pagpasok ng COVID, ang lahat ng school at review centers ay natigil. Liban lang, of course, sa Padilla Review Center. Ang lahat ay nag-migrate sa online. Iba-ibang pakulo, iba-ibang style. Ang mga estudyante sa pagpili, lalong nalito, lalong naguluhan. Pero para bigyan kayo ng mas clear idea on how we do it actual in our online review, we created this channel para nakikita nyo ano talaga ang mangyayari, paano namin ginagawa sa loob ng Padilla Review Center Online. All links are found below this video. But before we begin with our discussion today, please don't forget to visit and to also like our FB page, Padilla Review Center. Nasa baba po ang link. Subscribe na rin po kayo dito sa YouTube channel namin. Huwag niyong kalilimutang i-click ang notification bell, choose all para lagi po kayong updated and notified sa lahat ng post namin. Para po sa inyong lahat ng nagre-review ito at nag-aaral ng engineering. Pati po yung mga BS Math, lahat po ng nagte-take ng Math. Pero hindi po limited sa Math, buong civil engineering specifically ang didiscuss namin kasama po yung ibang subject sa ibang engineering, mga common subjects like mechanics and strength. So, kung may mga request po kayo na problem, ipadala lang po dito sa YouTube channel namin and then isya-shoutout po namin yung kung kanino nanggaling yung problem na yon and hindi lang siya shoutout, isosolve po namin. Today, I would like to discuss to you how to do double integration method in solving the deflection, the rotation of a cantilever beam. So, let us begin. Now, the principle here or the key equation is that the EI y double prime, meaning second derivative of y is the deflection, is equal to the generalized moment equation. Generalized moment equation is the equation for moment near the right end of the beam, okay, extreme right, okay. I'll explain this in our sample problem, okay. Now the cantilever beam shown has EI of 10 to the 6 kilonewton meter squared. We're asked here to find the rotation and deflection both at point B and C. C is the free end, B is 3 meters from the fixed end. Now, for consistency of the presentation for other future problems on double integration method, whenever you encounter a fixed-ended beam, so put the fixed end on the right, okay? So, I will just twist this 180 degrees, okay? So, it would be something like this. This will be the support now. This is now point A. This is our uniform load, that is 10 kilonewton per meter. And this is our concentrated load, 30 kilonewtons. So, this is downward. Okay? Point B is here. Point C is here. So, nagkapalit lang. Inikot natin. So, they are just interchanged because we twist it. Rotate it by 180 degrees. Okay? Now, what I am referring to by the general moment equation is you write the moment equation very near the right end. And the distance of this section from the left must be called x. Okay? So, x is from here to the section. So, your x is the distance of the section from the left end. At this point, x is 0. At A, x is 4. At B, x is from the left end, 1. You follow? Okay. Let me write now my moment equation. The key equation is that AIY double prime is equal to, what's the moment here? This is now the significance of what I taught you. Kindly review in the first part of this structural analysis series, part 1, when I discuss moment equation. So the moment due to 30 kilonewtons, that is downward load, is 30 times x. And that is downward. I put here a negative sign because that is a downward bending, downward moment, negative moment. Minus, again minus, because this load is downward, it causes downward bending, right? So it causes down moment. So it would be the moment due to this load, Wx squared over 2. So that is 10 x squared over 2 and nothing else. So this is your AIY double prime. So what we are going to do now is we integrate this. So integrating this, both sides, okay? So integral of second derivative, that would be first derivative. So you will have your AIY prime equals minus integral of 30x is 30 x squared. Integral of x to the 1 by power formula is x squared over 2. Minus, this is 10 over 2, this is 5. Integral of x squared is x cubed over 3. Since we integrate without limits, so we have to add a constant of integration. Let me call it C1. Let me call this equation 1. Equation 1 is y prime equation. Okay? So this will handle our rotation problem. Okay? Now, again, integrating this again, integral of this will be, for the second time, integrate everything. Integral of y prime is y. You get it? Equals, you have here minus 30 over 2, 15. Okay? Integral of x squared is x cubed over 3 by power formula plus 1 over the result. Okay? So minus 5/3 integral of x cubed. This would be x to the 4th over 4 plus C1 integral of C1 dx. C1x, we integrate without limits, so you have to add the constant of integration C2. So let me call this equation 2. Lagyan natin ng t, temporary. Okay? So our only problem here in double integration method is finding C1 and C2. So no other concepts to be memorized. No elastic curve to be drawn, no equations from elastic curve to be drawn, no moment diagrams to be drawn, just the moment equation. So the only additional job here or work is finding C1 and C2. How do we solve them? This is it. Since this is cantilever beam, the key here is the support. At the support A, we know that this is support, there is no deflection, right? So at A, x is, what is x at A? X is the distance from the left end. It's 4. X is 4. What is the y at A? 0, because there is no support, right? What is the theta at A? This is YA, theta at A. What is the theta at A? The theta at A for small angle, and if this is in radians, this is approximately also equal to the tangent of theta A, provided theta A is in radians. And we learned from our calculus that the tangent of theta with the x is simply equal to y prime, dy dx. That is this one. So approximately for small angle, y prime and theta are equal. You get it? Okay. So, but we know that this is fixed. This is fixed. So therefore, the theta here, there is no rotation. So at A, this is going to be 0. We have two zeros for the equations. Look here. If we will substitute here in equation 1t, equation 1t, when x is 4, you have y prime is 0, right? Correct. So you have here 0 is equal to minus 15 times 4 squared minus 5/3 times 4 cubed plus C1. This will give us the value of C1. Solving our C1 is equal to, let me compute. Move this to the left, so you'll get positive, okay? So this is 1040 over 3, right? Okay. Now, also using equation 2 temporary because there is no value for C2 yet. So, when x is 4, our y is also 0. Okay? So, substituting it here, EI times 0. So, 0 is equal to minus 15 over 3 times 4 cubed minus 5 over 3 times 4, 12. 5 over 12, x to the 4th, that is 4 to the 4th, plus C1 x. C1 is 1040 over 3 times x, which is 4, plus C2. This will enable us solve C2. What is C2? Let us put this in memory C of our calculator, na? So, times 4 minus 5 divided by 12 times 4 raised to 4 minus 15 divided by 3 times 4 cubed. Move to the left. So you have here C2 is equal to minus 960. Okay? So we have the value of C1 and C2. What do we need? We need theta at B, which is now here, and theta at C. So, at C, what is our x? Our x is 0. So, substituting here to equation 1t, at equation 1t, you'll have here our EI y prime. So you have EI is 10 to the 6, y prime is theta. This is theta at C. Is going to be, x is 0, this is 0, this is 0. So that would be C1, right? So 0 plus C1, which is 1040 over 3. So your theta C is going to be equal to 1040 over 3 over 10 to the 6. So that is equal to 346.66 times 10 to the negative 6, and this would be in radians. You follow? You get it? So for deflection at C, we go to equation 2t. So you have here in equation 2t here, EI is 10 to the 6, y at C, x is 0 at C. This is 0, this is 0, this is 0. So therefore, we just have C2. And C2 is minus 960. So therefore, we will have here YC is going to be minus 960 over 10 to the 6. Or this is going to be minus 960 times 10 to the minus 6 meter. The negative sign is an indicator that our Y is downward. The Y at C is downward. And the theta at C, this is positive, so it means it is clockwise. Why is it that in our previous problem, it was negative? Because we twist our beam. In the actual figure, our theta C will be something like this. It would be clockwise rotation. But in here, it becomes, we twist it here, so it will now be counterclockwise rotation. So here it is positive, it is here negative. What about rotation and deflection at point B? We know that at point B, our x, the distance from the left end is 1, right? So x is 1. So considering equation 1t, you'll have here ei y prime. So our y prime is the same as theta. So ei is 10 to the 6, y prime at b is the same as theta at b in radians, is equal to, just substitute x is 1 here. So you have here minus 30 over 2 minus 15, x is 1. So that is 1 squared. Okay? Minus 5 over 3 times x cubed, 1 cubed. Plus C1, our C1 is 1040 over 3, right? So this is 1040 over 3. So this will enable us solve theta B, and this is equal to all of this divided by this. So let me solve. Minus 15 minus 5 divided. So you'll get here 330 times 10 to the minus 6. And this would be in radians. If you want to convert it to degrees, just multiply by 180 over pi. Now, substituting to equation 2t, you'll have eiy, you'll have ei, which is 10 to the 6, y at b is equal to x is 1. If x is 1, this is 1, this is 1, this is 1. So I have here minus 15 over 3 minus 5 over 12 plus C1 times 1. C1 is 1040 over 3 and plus C2. C2 is minus 960. Solving our YB is going to be all of this divided by 10 to the 6. So it's minus 618.75 times 10 to the minus 6, and this is in meters. The advantage of double integration method is it doesn't need a moment diagram, it doesn't need a tangent line, it doesn't need an equation involving the tangent line, the deviation, and the deflection. So you only need the generalized moment equation. Integrate it twice, you have the deflection equation. Integrate it once, you have the rotation equation. Do you follow? You get it? Okay? So if there is no specified method, you can always go to this method. So the only downside of this is solving your C1 and C2. Kuha niya? I am inviting you to attend our special course, most especially if you are a first year college. So we are inviting you, I am inviting you to attend our course, to enroll in our course in Theory of Structures. It is divided into two parts, part 1 and part 2. So that is, part 1 is statically determinate structures. Part 2 is statically indeterminate structures. So you will be learning a lot from this program, and we are offering it at a big bargain price today. So it will start on February 15. So if you will enroll on or before February 15, your tuition fee is only 500 pesos for part 1 or for part 2. If you want to enroll in both, so much the better. So, see you